morning. Welcome to the second lecture of Safety and Risk Analytics. Today we will be discussing on hazard triangle under Module 1 Basics of Safety and Risk. The concept that we will know today are hazard theory, hazard incident entity, hazard actuation, hazard triangle, and some examples. Certain portion of today's lecture is taken from Erickson CA 2015. One of them is this one, hazard incident, hazard to incident, that is hazard theory. Last class I have discussed some of the definitions including hazard and incident. You have seen those definitions. So we have discussed hazard is the potential condition that can cause harm, loss, damage, etc. And incident is basically the real event which is resulted out of the hazard present in the system. And from hazard to incident, the path is known as incident path, and we say a system can have two states. One is the potential or hazardous state, another one is the incident state. So the state transition from hazard state to incident state is described with the help of incident path. And the incident path is governed by hazard components, and we have discussed in the last class that there are three hazard components. One is hazardous element, and then incident causing mechanism, and target and threat. So there could be other factors which actually either influence in the sense that it may aggravate the situation, or it may improve the situation. And when things aggravate the situation, so we say it is basically the risk factors. So there could be several risk factors which will also enhance the incident actuation if not corrected properly. So that is basically in nutshell we say the hazard theory, that means hazard to incident. Last class I also discussed that hazard potential is measured in terms of risk, and in another way you can say this is basically hazard incident entity. This is basically the amount of hazard potential or the amount of harm that an hazard can cause, and I have discussed in the previous slide the transition path also. So here once again we are I can say that we revisiting the hazard and incident definition in terms of examples. Hazard example is wear and tear of oil pipeline may lead to leakage of oil, which may result into fire and explosion in the vicinity of ignition source. So if this is the hazard, then the incident which is other side of the coin, we can say that wear and tear of oil pipeline led to leakage of oil which resulted into fire explosion in the vicinity of ignition source. So you can find out that that oil pipeline is the hazardous element, wear and tear is the initiating mechanism, and leakage of oil is the pivotal event, and then which results into fire and explosion accident, which is basically source, I can say the threat as well, and it ultimately resulted into may be the loss of property, injury, other things. And obviously in order to have the fire, ignition source is also required, which is another pivotal event. So if hazard is documented in this manner, then actually you know why the incident or accident is going to happen. So during hazard identification process, if you take care of these issues, then you are in a position to tackle the situation so that hazardous state will not be converted into an incident or accident state. Next, I will show you that what is hazard actuation. I said that hazard state is transformed into an incident or accident state. So the state transition, how it takes place. Conceptually, if you consider a plant, any system, or even a job, you will find out that the initiating event, hazardous element, initiating event, several pivotal events, as well as different kinds of threats and people, property and environment, these targets are always available. Most of the times it will be available, but what actually happened, they are not aligned to complete the state transition from hazardous state to incident state. Why? Because these are, even though these things are there in the system, but they are taken care properly so that the alignment, like what you are seeing here, the alignment from hazardous element to threat and target, that has not been taken place. So we are dealing with system, plant, machinery, job, everything with all those elements. But at the same time, we have to be very cautious. We should be vigilant about that, the alignment, which is basically some kind of chain of events that could occur and which ultimately make possible the state transition. So you should not allow. So what is hazard actuation then? That means hazardous element will have certain initiating event. You should not allow the initiating event to occur, and the initiating event with the presence of one or more pivotal events that can ultimately lead to the incident and which ultimately pose certain threats to the targets. So you should not allow this to happen. Now, issue is that if I say that how it could be analytics driven, then we need such chains or paths, whatever could happen, that to be identified, documented, and if already happened, so those things should be used for verification point of view. So in the process, you will be able to quantify all those elements of the path in terms of their probability of occurrence as well as the probability of occurrence of the entire path. So all those details will be discussed in this particular subject in the subsequent lectures. So that means what is hazard actuation? Hazard actuation is nothing but a series of events leading to incident or accident and causing certain loss in terms of human safety, in terms of property damage or environmental discharge. As I told you earlier that you need to have the elements aligned in terms of sequence of events. So that actually hazard incident actuation is defined in another way, like the Swiss cheese model way. What actually we are saying here, that you see that the few circles here. So here hazardous element will be there because of the functionality it is required. So this is one hole. Hazard should not be there ideally, but you cannot have any system without hazard. The way we are defining hazard, potential condition to cause harm or loss, it will be there. Second is that incident causing mechanisms like initiating event and pivotal events, so this also will be there. The reason is that in order to arrest the hazards to become an incident, you also put certain amount of other measures, either hardware or software or humanware, which ultimately take care of the situation that hazard will not become an incident. But those things, those elements or those subsystems or components, they are also fallible in nature. You cannot expect a machine will work all the time without failure. Similarly, a human work all the time without failure, and a software all the time work excellently. You cannot. So there will be some events that takes place which triggers the path, or I can say the beginning of the path. And then subsequently the other elements or the system components will take care, and the primary role is that they should become successful so that the hazard will not become an incident, but they are also fallible in nature, and they are the pivotal events. So these things or these events, like hazardous elements aligned with the other elements of the incident causing mechanism, if aligned together in a series of events simultaneously, then what will happen? The accident will take place. So, nutshell, what is the logic here? That we are dealing with hazards. Hazard has many components, and ultimately they remain haphazard, and as a result incident will not take place. But if you are not vigilant enough, the alignment like this on a particular time, all those loopholes will align together and incident will take place. You don't want this to happen. The second figure, the bottom figure, you don't want. The top figure is the hazard, bottom figure is the incident. This is another way of understanding hazard incident actuation. So this is also similar to the previous one. We say that hazard state is the condition, and incident state is the event. So again I am repeating the same thing, that condition is by design. If you want to produce, you have to have a system which will be having certain hazards, and that hazardous state or the condition is by design. But at the same time, by design it should be taken care of that the hazardous state will not become an incident state, and several preventive and protective measures will be in place. Even then, the transition may take place because of many things, that energy build up, then point of no return reached, level of safety degraded, and all those things when aligned together on a particular time, the line connects, chain of events completed, and incident will take place. I hope that you understood the concept that from hazard to incident or hazard to accident, and what is the general concept, what is the general philosophy, and what a safety engineer or safety manager must understand in the beginning, whether he will be going for analytics driven safety management or traditional safety management, but this is a prerequisite and must be understood. Next concept is hazard triangle. Hazard triangle, very important part. If you want to combat with hazard, if you want to arrest hazard in such a manner it will be in a passive state, then you have to understand hazard triangle. The traditional way of understanding hazard will not give the benefit that we should look for, because hazard is understood in a different manner. But in the safety engineering terminology, what Erickson too has given, that hazard should be understood in terms of hazard triangle. So what is hazard triangle? We have adapted, or I can say the concept from Erickson, but we have modified little bit. Erickson says that hazard triangle comprises hazardous element, initiating mechanisms, and target and threat. We have adopted in this manner hazardous element and target and threat. Hazardous element, target and threat, fine. But instead of initiating mechanism, we are saying incident causing mechanism, ICM, which basically composed of initiating event and several pivotal events. The pivotal events may be one or more than one. Initiating event is the starting point, which ultimately talks about degradation of the safety system or the safety measures. So that is the starting point. So with an example, let us understand what is hazard here. We are saying wear and tear of oil pipeline may lead to leakage of oil, which may result into fire and explosion in the vicinity of ignition source. This we have described little earlier also. If you want to understand the component with reference to this example, then you just follow this table. What is hazardous element? Hazardous element is basically something, the source. So that source is here oil pipeline. So what is initiating event? Wear and tear. Oil pipeline should be properly designed, maintained and operated, so that the wear and tear will not take place in such a manner that it may ultimately lead to certain adverse other events. So initiating mechanism is wear and tear. If wear and tear takes place and it goes beyond the safety limit, then leakage of oil will be there. So this is one pivotal event. If leakage of oil subsequently experience a source of ignition, what will happen? It lead to fire and or explosion. So as a result, that our hazard components are hazardous element, oil pipeline, initiating mechanism, wear and tear, pivotal events, leakage of oil and ignition, and then threat is fire or explosion. Who is the target? Target is human, property or environment. Depending on what kind of threat is there, that sometimes it will only be threat to the people, sometimes it will be threat to people, property and or environment, or a combination of the three. So when we go for hazard identification, these components must be kept in mind, and when we write or represent hazards based on our certain schemes, so when we are basically identifying the hazards, we must be able to write hazard in this fashion, because if you write hazard in this fashion, you are also writing that why and how the accident or incident is going to happen. You are also in a position to find out the appropriate safeguard in terms of risk control measures or risk control systems. All those things possible much before the hazardous state is converted into an incident state. So that is the sole purpose of hazard triangle. If I say what is hazard, if you say fire is a hazard, we will not accept it. If you say driving a car is a hazard, or if you say the faulty equipment is a hazard, we are not going to accept it in the sense because it is not giving you the complete picture. Hazard identification is one of the most important activities, and it should be done, and it should be done correctly, because the hazard knowledge is extremely important for safety and risk analytics to become successful. From the hazard identification, and the documentation of it, you will generate a lot of data. And IIT Kharagpur is working on it, which we are talking about. We have termed as micro hazard mapping and management. So, okay. So I hope that you understood that the hazard triangle, and we will give you certain examples of hazard triangle further, and all those things you have to practice, and then only you will be master in writing hazards, identifying, representing and documenting hazards effectively. So some examples I have created for your benefit. For example, just these are these examples are hypothetical examples. So you can create also based on your system knowledge. What we are saying, a workers work at height without using a safety harness. In certain circumstances, he might feel dizziness and fall on the floor. This may result in injury to the worker. So when you are going to, you identified hazards, you have gone for to identify hazards at a particular workplace. You have seen this and you have documented in this. If you document in this manner, actually you have documented also the hazard triangle. How? Here the hazardous element is working at height. Now, if we want to know what are the incident causing mechanisms, so that means how working at height can lead to an incident, then the working without a safety harness, as per standard operating procedure, safety belt should be used when you are working at height. So it is not used. So that is the initiating event. And because of the height, maybe some other risk factors like temperature, or maybe the health, sudden change in health condition, all those things may lead to that feeling of dizziness. So this is the pivotal event, and these two ultimately lead to that what the accident is, fall from height. So the incident or accident fall from height ultimately pose the threat, injury, and here it is related to workers. So what I mean to say, that means the traditional way of identifying and documenting hazards will not serve the purpose, because for safety analytics. Safety and risk analytics require good amount of hazard data, and those data should have collected in such a manner that the hazard itself will speak for why and how incident is going to happen. And that is the sole purpose we are giving this hazard triangle, so that you will identify that what will be a hazard data table. That is the purpose. Okay. Now see, the way we have written here the hazard, if similar situation and fall up from height will occur, what you will write? You will write an incident exactly in the same manner. Only thing is that you say it has occurred or occurred. So worker was working, here a worker works. Then we are saying without using safety harness, same. He felt dizziness, we say he might feel dizziness. and then fell on the floor. We here say fall on the floor. So fall is become fell, might failed, fail become failed, and that resulted in injury. So may result become resulted. So if hazard identification and its documentation are done correctly, you just see that when you go for an incident investigation, parallelly if you search for the hazards inspection or investigation report, hazard identification report, you may find one-to-one correspondence. Okay, so this is basically the aim. Okay, now let us go for the another example. So our second example is a crane at a construction site is engaged in lifting concrete slab. So crane is engaged in lift of concrete slabs. The weight of some of the slabs are beyond the lifting capacity of the crane. So overweight slabs are there. The crane hook might break, resulting in fall of load and broken hook. This may result in injury. So what is our hazardous element here? Overweight concrete slab. It should not be there, but anyhow sometimes it is there. This is energy. And then if you go by the incident causing mechanisms, the initiating event and your pivotal event. So lifting of overweight concrete slab is the initiating event. It should not be lifted because it is overweight. And the breakage of crane hook is the pivotal event, which results into basically the fall of load and the hook, and that may result into losses to people, property, and that is what is written here. And if you read the hazard and incident definition again, you will find out the one-to-one correspondence, only the transition has taken place. Okay. So in similar manner, several examples can be created, and those examples ultimately will help you to understand hazard triangle in a full manner, and I am sure that you all will be able to do this for your own system. If you are an industry practitioner, you take your system. If you are a student, you take a system where you have certain knowledge and try to find out the hazards and document in this fashion. So this is another hazard, explosion in the dryer. Actually it is related to some kind of process incident, and then we have gone for some another hazard which basically road incident point of view, and another one we have taken from the software hazard point of view. So we have chosen 5 hazards here in such a manner that will cover the process hazard, equipment hazard, and then software hazard and human hazard. For example, the working at height without safety harness, safety belt, it's the problem with the human. It is not as per operating procedure. Similarly, a software bug not detected and not removed by software team, a computer controlled radiation therapy may expose to the patient to higher level of radiation. This may result in numerous deaths. So this is from a healthcare system, but this is a failure of the software. So here radiation is the, I can say the radiation, okay. Here all those five hazard is given. First one is working at height. Second one, lifting of overweight crane, slabs, alkali and crystal ringing, car and bike, and radiation. These are the hazardous elements. Basically, these are the source of hazard. Now, initiating mechanisms, working without safety harness. Second one, lifting of overweight slabs. Third one, improper water ranging. Fourth one, turning of car without radiator indicator on. And fourth one is bug in software. So I can say the working hazard, this may be that human hazard. This lifting of overweight concrete slab, this is a equipment related. Alkali crystal, that ranging process related. Car and bike road related. Bug in software related. Okay. So it need not be that all the time your hazard will be only human or equipment or process or software related, but there can be combination of all those things. Okay. Then what is our pivotal event here? Filling dizziness, breaking of crane hook. Here are two pivotal events, PB1 and PB2. And then here also two, PB1, PB2. And here non-detection and non-removal of bug. That is also detection and removal that has not taken place. And in addition to this, in addition to hazard triangle, we have added another important features called RCS, which is nothing but risk control system. Actually, although the incident causing mechanisms to be understood, and at the same time you have to understand also that what you should do so that these incidents will not occur, probable incidents will not occur. So under risk control system, there are many efforts, measures, either engineering or administrative controls. These are there. So you have to understand, suppose in the first hazardous situation, you have to parallelly check that why it has happened, because which risk control system failed. So operating procedure and is one risk control system. So that means either there could be two ways. Either the operating procedure was not available to the worker, or he might not have been trained, or he might be a risk-taking person. So this one for prevention point of view, and second one, if the fall take place from injury mitigation point of view, emergency arrangement will be there. So there are 9 risk control system given by HSE, Health and Safety Executives, in 2006. So they are basically plant design, plant change, operating procedure, instrumentation, alarm, inspection and maintenance, communication. In this manner, many things are there. So what you require to do when you go for hazard identification, not only you identify the hazard triangle and also identify the incident path, at the same time also you identify that what are the risk control system that should have been very active, or that should be active in this situation, and under which risk control system these kind of incidents may be clustered or grouped. Okay, so that is very important. So this risk control system is very important. There are 9 RCS we will be discussing later stage also. Okay, so I will go to the next slide now. Now, as I told you that when you go for hazard identification, so there are many ways of hazard identification. First of all, there are certain programs. Basically, under hazard identification and risk assessment, there are many programs. Some programs may be once in a year or at some periodic interval. But 2 important programs. One is basically inspection and workplace inspection and certain visit and observations by certain group of people. And another one is safety audit. These are the programs which are basically done to make workplace safe. Okay. So when you are documenting the outcome of each of the programs, please keep in mind that are you documenting hazard triangle and the risk control systems or not. So that's why we say when you are creating hazard database, we are basically promoting the idea that in safety audit report or inspection report or observation report, the report must contain these things. What are these things? Hazardous elements, incident causing mechanisms, where incident causing mechanism contains initiating event and several pivotal events, threat, target, as well as what kind of incident or accident that could happen. This is a must. In addition, there are many risk factors that to be there, like location factors should be there, times factors should be there, individual factors should be there, system related factors, organization related factors, so many risk factors are there, and brief description of the hazard inspection report, also hazard inspection or hazard observations or safety audit, that also should be there. So please keep in mind that we are basically focusing on that how to collect data when you are doing different kinds of I can say that scheduled programs from hazard identification point of view. Okay. Now another source of hazard data will come from the incident investigation data. Whenever accident takes place, so what actually we do, suppose accident takes place, so immediately there will be investigation, and based on this investigation reports will be prepared. And the investigation reports not only prepared by the nowadays by the team, but now what happened, there are other sources also. You will get different kinds of information for incidents. If it is a low level incident, then it will be within the company level. If it is a severe one, catastrophic one, then it will be a international news. So something like this. But at the very basic level, when there is an incident at workplace, then obviously the management prepare or makes a team, and the team visit and observe and inspect the entire incident events, and they prepare report. This incident report usually will be in the form of text, unstructured text data. And ultimately what is required, that from unstructured text data you have to make structured text data. And if we want to know the hazard and incident causing mechanisms properly, that means the report should have information related to this, that hazard triangle, incident path, as well as risk control systems. So we have to keep in mind that when we are investigating any incident or accident, are we putting enough information so that later on this report will be used as the input for data driven safety and risk management. So that is possible when the information given in the report is quality enough, and the information which required further for doing analytics is possible. Okay. So we will discuss all those things that later on, but means how the from incident data to you will finally get this basic information. So again I am repeating what we are basically propagating here, or we are promoting. We are saying that okay, whatever you are doing, fine, but please keep in mind that you have to generate data. We believe in data. The hearsay will not be believed, and at the same time, if you want to use the analytics, you have to have data. The first level data, important data, is hazard data. So whatever you are doing, you must see that these elements of hazards are there in the data set, someone will be able to extract this. Or if it is already extracted and written in the report in very structured format, that is also well and good. If not in the structured but in the unstructured format, some text are given, but these elements information must be there. In addition, other risk factors will be there, as I told earlier also. So, this is my first data table. This data table is prepared by IIT Kharagpur with the help of existing literature. What we are saying that the minimum data table for hazard. When we do hazard identification, the minimum data table is this: hazardous element, initiating mechanism, pivotal events, probable incident, threat and target, which risk control system is responsible, and then brief description about the hazard and other related information. This table is a very important table for safety and risk analytics to be practiced. So, every year we in the industry do lot of such programs. So, if we have concrete data, if we capture the data and store it, that means it will be one day millions of hazard data will be available with the organizations. And then this all machine learning techniques, data mining techniques, all those things will be useful, and you will be able to do including predictive analytics. That is possible. So, this is not the entirety of the data, please keep in mind. This is what we are saying, the minimum data from the hazard point of view. So, not only hazard data, there are design data, operation data, maintenance data, many other data that slowly you will come to know. In fact, you know many of those things. So, this is very, very important. Okay. Now, one homework I am giving to all of you: consider a plant, machine or any other system where you have sufficient functional and operational knowledge. Generate a possible hazard data table for the system considered. Based on this lecture, you prepare a hazard data table. What you learned? You learned hazard theory, you have learned hazard triangle, you have also learned that how to create hazard triangle using different kinds of incident and observations as well as incident investigation. At the same time, you have also learned that what could be the minimum hazard data table for safety and risk analytics to become possible. Okay. So, these are the references, and some of the references are quoted here, but in the process of making the slides, we have taken our own references based on our 30 years of research and teaching and consulting experience, but we have not given here, doesn't mean that those references are not to be included. Okay. So, thank you for your patience, darling. We will see you in the next class.